Alrighty guys, today we're going to go over how to utilize voltage sampling in MyPlasm interface. So if we look at the screen, I have it similar to the other video. If you haven't watched that, that's the Arc Pro Automation voltage sampling video. You have the same functionality in MyPlasm, so I just wanted to go over that quick. So we have a part here that has all rounded corners, and obviously this circle in the center has no points or corners on it. So the purpose of this shape is the same as when we do torch height control calibration. This is going to be a simpler method of that, but it definitely has its place where you're going to need to do some of the same steps that you would normally do in a THC calibration, except for in this it does some of that for you. So for instance, this part that we drew here, it has all rounded corners, and then obviously the circle in the center, that's going to maintain velocity through the duration of the cut. So that's very important during THC calibration because we don't want to see any voltage spikes. And when we see voltage spikes, generally that happens when we're coming into a corner, we're decelerating or accelerating out of it. The material that in the cut path gets pushed away, leaving a greater kerf width in those areas slightly. And with that larger kerf width or larger cut path, it's going to in turn increase voltage, especially as it starts to go into that corner and it dwells there for a split second when it changes directions. It's going to have just a raw open arc in that corner. So you're going to see the voltage go from maybe 130 up to 150, 160 for a split second into those corners. So with this part where we have these rounded corners, that never happens. It can just continue at a consistent velocity all the way around the cut profile. So that's the purpose of the part. Now to get into the sampling method, you'll notice over here we have 68 volts on our THC, or cutting height rather. So if we change this voltage and we make it a 0, what that's going to do is going to activate torch height control sampling. When that's 0, what it's saying is when we started this cut, so right here at this lead-in or even this center lead-in on this circle, it's going to cut the lead-in, and as it starts to enter into the cut profile, about 1 inch or so into this cut profile, the THC, even though it displays that it's turned on, it's going to remain off for the duration of that behind the scenes. It gathers a voltage from the starting point of that profile all the way up until that 1 inch or so where the THC is going to turn on. But when the THC turns on, in this zone, it gathers a voltage and it takes an average of the voltage it sees, and then it updates the voltage on the back end that it's calibrating to for the duration of the cut. So from here, it does a touch off. It's going to start about the first inch to inch and a half of the cut there. It's going to have THC turned off behind the scenes. It's going to average the voltage that it sees, and then once it surpasses that point and keeps cutting, it's going to maintain whatever the average of that voltage was. And it would do the same for this outer profile and every other cut after it, so long as this is set to 0. You're not going to see that voltage in here. It's just going to stay at 0. So that's the gist of THC sampling or calibration. Now, when you're going to be using this function, it is very important that you do look and get a visual at the torch height and make sure that you are at 60 thousandths. Now, if you are above 60 thousandths, say at 1/8 of an inch or 100 thousandths, 200 thousandths, during that duration where it starts the pierce and then cuts when it's doing the average, if you're at, say, 200 thousandths and it's seeing a voltage of 145 and you've never confirmed visually that the torch is indeed 60 thousandths or a 1/16 of an inch away from the material, then it's going to use the average from whatever height it's at. So keep that in mind when you have this set to 0. You would want to make sure that you are at 60 thousandths, and then once it gets to the end of that profile, it would kick on and it would use that average, and that average would be correct relative to that voltage gap that it should be set to based on hypertherm or your other plasma cutter, depending on the plasma cutter you have. You'd want to obviously see what their ideal cut height is and then set it to that. So in this case it'd be hypertherm, that's 60 thousandths, so we're looking for a 60 thousandths voltage gap, and then once we see that, we can utilize that sampling mode. It'll take the average across that 60 thousandths height for a 1 inch to 1.5 inch area, and then once it surpasses that point, it's going to go on utilizing that new average value as the torch height control arc voltage. So thanks so much for watching, guys. That's a lot of information. It might be worth it to watch that once or twice. just to fully understand it. And if you have any questions, feel free to call us, or you can reach out to us directly at support@squickmons.com. Or if you have a video request, you can go on our website to the Contact Us form. You can put a video request into there. We'll do our best to get to those videos as fast as possible. And thanks again, and we look forward to seeing what you do with your new CNC plasma systems.